Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining me. Technology has always been recognized as a driving force in factory automation. But how often is it recognized that it's not the only driving force? A seldom acknowledged statistic is that the workforce has been destined to decrease ever since the baby boom ended in 1964. Automation is needed because the workforce is shrinking. Since Henry Ford began building cars, the heart of every factory automation system has been a reliable conveyor system. And as consumer and product demand has grown, so has the expectation for faster and faster production cycles. And the market for conveyors has grown right with it. Conveyors are growing to a market of in excess of $7 billion. But with that expectation and growth comes an increase in system complexity. It has become a field for specialists. The conveyors used in applications like material transfer, product packaging, or part assembly integrate sensors, transducers, and even AI to match the right material with the right location at the right time. But who designs them? Are the users expected to be fluent in all the nuances of conveyance systems? To work through this process, we embark on a 3-episode series here on Evolution in Controls on conveyor design. Helping us are two guests. Kevin Curtis is the branch manager for Morrell Group, and Mason Cole is a senior sales engineer for Bosch Rexroth. Guys, thank you for joining us today.
Thanks for having us, Tim.
Hi, Tim. Good to be here.
Good. So let's start with the basics. What kind of processes can be automated where they're using conveyors?
Automotive assembly, engine assembly, head assembly, test, transmission for the automotive.
Okay.
Obviously.
What about non-automotive? I assume there's other applications.
Sure. Yeah, absolutely. I mean, really, the gamut of industry, right? So food and beverage is a huge one right now. Packaging, right? So anything that can be automated, there has to be some sort of transport, and that's really where conveyance really slots in well.
Okay. So in the automotive, engine parts are on the conveyor system, I assume.
Correct. Yep.
And they're moved around. In food and beverage, are they actually putting food product on the conveyor?
In some cases, yes. For our VariaFlow conveyor, it is non-food contact, so we do have it's typically the packaging that's on our conveyance. So after the product is packaged, whether that be in a bag or a pouch or whatever it may be, a case it could be, that's usually what we're transporting.
Are they doing things like ketchup in bottles and soda in?
It could be anything from ketchup in a bottle, jam in a jar, chips in a bag, cookies in a box, whatever it could be. That it does require transport.
They just don't put the chips on the conveyor.
Correct. That could make a mess.
That could make a mess. All right. So what are some of the specifications about it? I mean, chips, they're pretty light. Engine components, they're a lot heavier.
Yep.
Is there a range in the weights that you can use the conveyors for?
Yeah, absolutely. So again, it depends on which conveyance system you're going with. So our TS conveyor is typically more of a general assembly. That's where you see more of the automotive applications. And our VariaFlow product is more for the food and beverage and packaging industries. Now, with the TS style conveyor, it can range from 3 kilograms all the way up to 400 kilograms. And on the VariaFlow style, it's in the 100 kilogram payload range. But again, that's very project specific and kind of what the application calls for.
Kilograms, you understand that in Canada.
I completely understand that, Tim.
Yeah, I have to.
Thanks for bringing that
Hey,
up.
we're a German company. We got to follow the German rule.
Okay, so essentially you're talking about 200 pounds to 800 pounds?
In that range, yes.
In that range, okay. And again, in the automotive industry, they're putting the parts right on a pallet or a workpiece? Is that, how does the conveyors differ?
So our TS conveyor series, it is a palletized product. So typically the arrangement is a tooling plate or some sort is attached to the pallet plate itself or machined right into the pallet plate, and then the product actually sits right on that tooling or nesting. And then the pallet runs on top of the conveyor itself.
So they might have the pallet plate be actually machined or something bolted to it, like a cradle.
Correct.
Okay. And on the other system, the VariaFlow?
Yeah, the VariaFlow system, typically the product is right on the conveyor. So again, a case, a pouch, whatever it may be. But we also have pallet options for that system as well. It's not as common as what our TS pallet system would be, but it's more for product transport from A to B.
I would imagine that the TS conveyor system may not go as fast as food and beverage. Are there speed differences or speed specifications, line speed?
Yes, and those are all things you definitely have to consider in the design process. Is one, what's your cycle time, but also what is that baseline conveyance speed to meet that cycle time. So in the TS world, we can get up to 18 meters per minute, even a little bit faster. That usually accommodates most applications. In the packaging world, things are much faster, so the VariaFlow does achieve much greater speeds than that, and to meet the demand of the production, because you don't want to starve your downstream systems if it can't meet rate with the conveyance.
Typically in the automotive industry, though, the part is moving to some kind of an automated station, I'll call it, or a human interaction. So speed isn't really a concern. You don't necessarily want to go that fast.
Right.
Is the concern precision? Are they worried about getting it to the right spot, or is it timing?
It's really the timing, right? The assembly. Say the spark plugs are going down. They're going to a station to be installed. You're installing 8 spark plugs. Mm-hmm. That takes time, right? Or if a human is actually stuffing pistons into a block, that takes time.
So some conveyor systems, I'm guessing, are very, very long. Are there length considerations that need to be considered?
Yeah, absolutely. Things to consider in a layout in general is just the overall configuration, right? So really the question is, obviously cost is always a consideration. So when you're doing a system, you want to get as much out of a single drive as you can, right? So there are length limitations for the TS systems. We can drive up to a 30-meter section, but there's also limitations on the capacity of it. And then on the VariaFlow style conveyance, you are limited to the load on the actual chain itself, of what that strength of that chain is, and that's all determined by how much product is on the conveyance and how much that product weighs.
And how long the conveyor is.
Correct.
And how much each product.
Correct. Because friction is a factor at that point as well when you get to super long lengths.
All right. So length, line speed, timing, those are all considerations. In the automotive industry, what are some of the what other considerations that need to be taken into account?
Environment, safety. Safety is a big thing, and energy savings, obviously, right? They're always trying to save money. Save energy, you save money, right? So, and safety is always a thing, because again, the humans are actually working side by side of these conveyors.
How do you save energy on a conveyance system? Is it because of the drive components?
Yeah, I mean, and again, it's all part of the design process, right? So if you can eliminate drives, you can eliminate, things like that where it may not be needed, and maybe think of a design in a different way. Maybe you can common drive a curve with a downstream unit, right? So there's ways you can save in energy efficiency, and it kind of goes back to your panel at that point as well. Less components in the panel.
That's fascinating. Let's talk about some examples of conveyors where conveyor systems are used. Give me, Kevin, do you have an example of?
Morrell we just quoted a system for a customer, and they called it the head loop. So that's basically taking an assembled head off the production line and looping it around to actually be able to create a excess inventory, I'll call it, because the machine was calling for more heads and the line couldn't allow it or accept it. Mm-hmm. So the head loop was more to be like a buffer.
Okay. What about non-automotive?
Yeah, non-automotive. One thing we see a lot is the food and beverage industry, right? A lot of people are going more towards automated systems. A lot of people started their own companies, and so in the food and packaging industry, with the labor shortages we have, they have to automate these systems regardless of how high the demand of production is, right? So just as an example, we worked on a project where they were putting chips into a case, and then the next step was palletizing those cases.
Bags of chips?
Bags of chips, yep. Okay. Bags of chips into a box, and the VariaFlow style conveyor was used to transport those boxes to infeed into a robotic palletizing cell. And in that case, it served as an A to B transport, but as well as a lot of it was manually done previously, so you're eliminating that labor need.
You mentioned a robotic cell, and you talked about another conveyor line that was already pre-existing. Are you able to take the Bosch Rexroth conveyor systems and add them to existing systems, or does it have to be Bosch Rexroth from start to finish?
It can be done. Depends on the situation. Certainly, as an example, again, in the food and beverage industry, is a lot of specialty type of equipment has conveyance already built into that machine design. So oftentimes we are marrying up to that equipment and kind of acting as the next step in the process, right? So it doesn't have to be 100% Bosch. And as far as the automotive is concerned, there's certainly cases where that can be done as well.
Okay.
To Mason's point, that's exactly what we did with the loop. It wasn't a Rexroth conveyor system, but the head loop was, we quoted Bosch Rexroth, obviously.
What about elevation change? Are there components that I need to lift it up or lower it down? Is that
Sure.
part of the components that we're adding?
Yeah, absolutely. There's a lot of, in most layouts, there's some sort of elevation change, especially in the food and packaging industry. Not everything is on a level playing field in that industry, right? So you do have elevation changes. And with the VarioFlow, we can actually accommodate that with a single drive. So you can have a flat, an incline, and then go to an outfeed of a different elevation. And then on the TS side, there's a lot of considerations for elevation changes. So lift and position units lift the pallet up for a robot to accurately operate on the piece of equipment. But you also have elevation changes for, it could be taking the pallet to a lower side level to return an empty pallet to the front of the system. So that's a completely different vertical transport at that point.
So we can add different components to an existing conveyor system. Can be lift, it can be same, it can be inclined. You're talking about what are more components of a conveyor system? We talked about
Sure.
lift. What else exists?
Yeah, so most conveyance systems in general really boil down to some key components. So with the Rexroth conveyance systems, VarioFlow or TS, you have your basic drive unit, you have your conveyor sections, and you have your return unit. So that's on both sides of the table. Obviously with TS, we have a lot more different modules, as we call them, to perform the operations you need to. So lift and transfer units, lift and position units, different various curves, elevators, to maneuver that pallet any way it needs to be transferred throughout the system. In the same facet on the VarioFlow side, we do have components as well to operate with whatever's recalled.
On the TS system, though, you've got to return the pallet back to the beginning.
Correct, correct.
So when you designed the loop, that had to be part of your whole design process.
100%. Customers really want to optimize the space, right? So they want to put as many pallets as they possibly can on that one run. But the problem is, once you fill it up, now you got to get the pallet back, right? So basically the pallet's got to come back to the front. So once it gets to the end, it's got to come back around. So
That's got to be considered at the very beginning of the design process.
Absolutely.
Are the customers able to do this design process on their own, or do they need assistance or guidance?
Oftentimes, it really depends. I mean, oftentimes customers really know what they want, but even still in those cases, there are optimizations that can be done. And that's where, folks like Morrell, as well as, with Rexroth's help, can really come up with a solution that fits the customer's need. And you claim to have experts out there that think they know what they want. Well, they know what they want, but we're the ones that have to decide how it should be done.
One thing that we didn't talk about is that Factory of the Future is something that Bosch Rexroth talks a lot about. If you have a factory environment, whether it's automotive or even packaging, there's a lot of factory information systems, there's a lot of feedback. How do they take that into account when you design a conveyor system?
Yeah, absolutely. Factory of the Future and factory automation in general is a big push across the board. Data is a big topic, and people want to use data usefully, right? So the question is, what do you do with that data, and how is it used? So the conveyor systems, things like Control-X that we have coming, it's an open interface type programming piece of equipment that can connect all of your production line equipment together, right? So you use that data, you can extract it, and then make it useful for your production. You can understand where your faults are, you can understand where you're slowing down, or you maybe have hiccups in the system.
So whether it's Factory of the Future issues, connectivity issues, whether it's the design of the return of the pallets, sounds like we have design expertise that we bring to customers. Did we do that on the automotive, Kevin?
that's exactly what we did. The customer had a bar napkin idea. We created a drawing for them, and we were able to fit it into the space that they gave us.
This episode of Evolution in Controls, we talked about the components, we talked about automating. This is actually a 3-part series. So on part 2, we're going to talk about the conceptual design of conveyors, and I hope you'll join us. If you'd like to learn more about Morrell Group's conveyor solutions, you can visit our website, morrell-group.com/conveyor-systems. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts, or on YouTube for a video version so you can be updated when we release new episodes. Thank you again for joining us. I'm Tim Wilson, and keep moving.